In continuation with the class, we have what we called projectile motion. Projectile motion. So it's a motion in 2D, like a motion in 2 dimension under gravity. A motion in 2 dimension under gravity. Example: you throwing a key up, so it goes in a parabolic path, so it kind of a curved path. So you throw it, goes up, so it won't come down the exact way you throw it, especially when you throw it at an angle, so it goes something like that. We have the next one, which is the circular motion. Circular motion, motion along a circle. So we refer to that as motion having a centripetal acceleration, kind of acceleration that involve a circle in a circular path, moving round. So that's that about that. So now we move to the next subtopic. Which is equation of motion. Equation of motion for constant acceleration. Equation of motion for constant acceleration. We have three major formula for equation of motion. The rest are just the derivative of this formula. So the first one, we have V is equals to U plus AT. V is equals to U plus AT. So the second one, we have S is equals to UT plus 1 over 2AT squared. So S is equals to UT plus 1 over 2AT squared. And the third formula, which is V square, is equals to U square plus 2AS. Now let's know the meaning of some of these symbols or some of these letters. So the first one, where we have the U, it stands for initial velocity. The first velocity the car is either moving. And note, when the car is moving from rest, or the object is moving from rest, the initial velocity is 0 because it's starting from rest. But in assumption, maybe it's already moving, so it will be having a initial velocity. So to the next one, we have the final velocity. That's the last velocity we could recall on that particular object. Maybe it moved from rest and at a particular speed, so that's the final velocity of that particular object. Now we have the acceleration, so which is the rate of change of the velocity, and we have the displacement or the distance, which is the distance moved, distance traveled, and we have the time taken for the object to move. And we have some keynote things that we should also learn under this topic, which is the graphical representation. Of equation of motion. So the first one, we have displacement-time graph. Displacement-time graph. In a displacement-time graph, the slope of a displacement-time graph is equals to velocity. The slope of a displacement-time graph is equals to velocity. The second one, we have the velocity-time graph. The slope of a velocity-time graph is equals to acceleration. So why the area under the graph is equals to displacement. We'll talk much about this in the next coming video. Now we have the acceleration. So the acceleration time graph. So in this acceleration time graph, the area under the graph is equals to change in velocity. Now to the next question. He said a cyclist moving at 12 meters per second brakes uniformly and come to a stop in 3 seconds. A. What is the cyclist acceleration? B. How far does the cyclist travel while stopping? So let's take a look at this question. You can actually give a try. Let me help you with some parameter. Probably you can give this question a try. So you have the cyclist. It's not from rest. So the cyclist initial velocity U will be 12 meters per second. the moment is stop, that means our final velocity will be 0 and our time is 3 seconds. So probably you can try and give a try calculating the acceleration, that will be from the equation of motion, and also alpha, which is alpha is saying that the distance traveled also. Okay, if you want to give a try, you can pause the video and actually give that a try. So now let's see the solution. So acceleration, from equation of motion, we having v is equals u plus at. So a, making a the subject of formula, we have a is equals v minus u over t, which is 0, which is the final velocity because it's stop, minus 12 over 3, and that will be 4.0. Wow, why do we get this negative? We have negative. Negative means that it is deceleration because it press the brake for the car to stop. So that's why we're having our final velocity to be 0. The car actually stop. So the negative in this acceleration is telling us that it is a deceleration or a retardation.